someone suggested that D. Shaw actually get the haircut from his thing, and I said, if you do that, I will give my talk in a wizard costume. I wasn't expecting him to actually do that. But conveniently, I had a wizard costume in my regular rotation, so...
Magically summon the beard.
The beard?
The beer.
The beer. Summon a beer. Abracadabra. Let's see if one comes. Sorry, I just have to figure this out. Linux is hard. So my talk is on playing with Duplo blocks and colouring with crowns. But first thing, though, I'd like to make a disclaimer. Maybe a wizard, but I'm into hex, but not hexes. So nobody needs to kill me. Okay. Right, so shit Ryan Dahl says. So this is from Node.js.org. Node.js is a platform built on Chrome's JavaScript runtime for easily building fast, scalable network applications. Blah, 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 event-driven, non-blocking, etc. I'm just going to tidy that up a little bit. Okay. Node.js makes it easy to build fast and scalable network applications. Node.js uses V8 with non-blocking I/O to make it lightweight and efficient. It's perfect for data-intensive, distributed, real-time applications. Now, this sounds pretty broad. What does this even mean? Network applications? Scalable? Easy? I'm not sure. This is like everybody says this shit is easy. I'm not sure if it's easy yet. But Ryan Dahl elaborates. I want programming computers to be like coloring with crowns and playing with Duplo blocks. Now, obviously, Duplo means modules with simple composable interfaces. And coloring with crowns is clearly like shallow customizations, templates, CSS, just easy stuff like that. Okay, so what are Duplo blocks? I mean, you have a whole bunch of different blocks that do certain things, and they have each Duplo block, although it may be different color, a different shape, the studs are always the same. Standardized connectors, so you don't need glue. Now that's really important. We want to not use any glue to put together our things. So also there's an overall vibe to what he's saying about Duplo and crowns, is that it's not enterprise server beans, it's not about feeling clever, it's just about things being easy and fun. So, in case you hadn't already guessed, studs is streams. Streams are not just for fast I/O, but they're for actually plugging programs together. And programs can be plugged together with streams on the same computer, but if there's a possibility that programs may exist on other computers, then they have to do I/O. So that's what makes streams the perfect, the shape, so that you have to use to connect programs together. So streams have been around for a long time, but the streams that were easy to do in the old days were the simpler ones. So reading and writing to a file, or the output of a command like ls or something like that. And then we have these transformation streams, like through, filter, transform streams. Now, I declared these were called through streams about a year ago. And that was the first thing that popped into my head. And I didn't expect everyone to listen to me. Isaacs has recently pointed out that through is a common word, and perhaps transform would be a better word for this kind of stream. And I'm inclined to agree with him. So anyway, those were easy to do in Unix. And like even in Bash, there is actually a syntax for having a duplex stream, but it's not simple. But there are these Unix commands that are duplex streams, like SSH, rsync, and git. Has anyone used any of these commands in the last couple of days? Well, that's a surprisingly small amount of hands, actually. I'm just going to guess the rest of you are lazy. Okay. So what makes these more interesting? So these duplex streams aren't just like something coming to you or something being transformed into something else. It's about two-way communication. So the first set of streams are the sort of things that you're using if you're building REST applications. Like they're cacheable, and the thing that makes REST scalable is you design your application so that every request and response is cacheable. And now with the sort of stuff we're all interested in doing in Node.js, caches ruin real time. So we're like, we'll put those to the side. We'll still use that for delivering static assets and that sort of stuff. But what about this two-way communication? So like SSH does a handshake to establish auth and secret keys, and then gives you a stream, normally to a shell. But before it gets that, there's been a few communications back and forth. Rsync is built on top of SSH, and it is basically like a conversation. Like a client connects, and he's like, hey, I'd like to back up these files. And the server is like, oh, does that match this hash? And the client checks if it does. Then it's like, oh, no, there's this difference. And then just sends the difference, which is much more efficient. And now both sides are the same. So Git works the same way. And SSH works, it does a completely different problem. But it is about sending messages backwards and forth. And the stateful messages, because I say something to you and then you reply to that, then I consider what you've said and respond back. And that was hard to do in Unix, but it's really easy to build duplex streams in Node.js. So if you see this pattern, piping something to something else and then back to the first thing, then you're looking at a duplex stream. So there's just a handful of these that have really been implemented so far. And they can be used to plug programs together. One that's particularly useful is mux-demux, which multiplexes streams through a stream. So if you have a budget on streams, so like you can only make a few connections through WebSockets, and the browser sets a limit on that, you can use mux-demux to stream as many things as you like through the single connection. So I think there's a good reason for this. The reason that it was hard in Unix and easy in Node.js is because a lot has changed since the dawn of time. Computers are faster. That's not actually that important. This is important, there's way more of them. I bumped into Robert Scoble yesterday coming through security at Heathrow, and he had 4 computers on him, and they all ran JavaScript. Now, that's a very different situation to what it was in January the 1st, 1970, when a sysadmin would have intimate knowledge of all the computers. If there was more than one, which is probably there was only one, computers that they controlled. And also, I'm guessing you've already seen talks that had slides about this, right? Yep. Yeah, that's stuff too. So also the network between like your cell phones and stuff like that are unreliable, especially at conferences. So that is like the most important thing really, just to accept that the network is unreliable. So is anyone working on systems that require scaled out servers, like where your thing is multiple servers? Right, good. Is anyone building applications that have multiple Node.js processes that maybe send messages to each other? Everyone keep their hands up, by the way, if you answer the first question. Is anyone building like a web mobile application that has like kind of complicated, interesting JavaScript that runs on the client as well as JavaScript that runs on the server? You guys are all building distributed systems. So let's just go for a simple example. Let's say Max has bought real-time cats, which is like a real-time service for cat photos. This I checked this morning. This domain is available actually. And Max wants to upload a new cat picture, but it's like real-time cats is so popular that he's got to like scale it out and run on heaps of servers just to cope with the incredible demand. I think Max is buying it right now. the outrageous demand for cat photos. But because cats are so popular on the internet, especially, another user is also uploading cat.jpg to the servers. So the user interface, it looks like here, is everyone gets an SSH user and can just log in and upload files directly. Now the problem here is, because this is asynchronous and over the network, there's no way to guarantee which commands will finish first. So two users are uploading a different file with the same name, and the order that it arrives on the servers is unpredictable. So if you curl that request, you won't get the same thing. It's not consistent. So okay, we've got to fix this. Distributed systems are hard, right? So we've got to make the order consistent, and then the results will be consistent. So we'll just have one special server that we send it to that, and then it will spend it out to the other files. But then we need locking, which is fun, right? And what happens if a server goes down while you're trying to send things to it? This isn't fun anymore. Like, it just got way harder when we added more servers, and that's not what we want. We want it to be easy and fun. So what about if instead of enforcing ordering, we made it so the ordering just didn't matter? So this was the old way, the old approach to distributed systems. When we had less computers connected to each other, we tried to make distributed systems act like local systems. But the new way is eventual consistency, and I think the term that's much easier to understand is commutative. You want to make your applications commutative. Now, what commutativity means, it means that the order doesn't matter. So A plus B is the same as B plus A. If you're building a thing and the order that the operations on it occur doesn't matter, then you'll get eventual consistency. So if there's one thing you take away from this talk, it's that you've added commutative to your vocabulary. So here's a commutative function for adding to your vocabulary. So we have this array vocab. We check that a new word isn't already in it, and if not, we push it onto the vocab, onto the list, and then we sort it because we don't want the order that we've added words to make a difference. Now, see, this is just a set. This is just a set that only grows. So it doesn't matter if you learned another word like eventual consistency first or after. Once you've learned both of those words, you'll have the same set. That's the important thing. This is the thing that makes it easy. So if we made these commutative, then it doesn't matter what order the real-time cats users uploaded their pictures. One of them would win, and it's not important. You can use a rule for deciding who wins, like the first update wins or the last update wins or something like that. Maybe you get the hash of the user and that's who wins. It's not important. The important thing is that the results converge, because then there's another thing about Duplo that we took totally complete granted, because it's just the default in the physical world, is that the effect of combinations is predictable and reliable. Like, you can consider, when you have two blocks that are plugged together, you can think of them as just one block. That's that face. That's that particular shape. You don't need to glue them together or anything like that. That's what makes Duplo simple. On the other hand, think of a house of cards. Has anyone tried to build a house of cards at some point? Yeah. How big did you get them? How big? How many cards? That high? That's pretty good. That's pretty good. But then you can't really build much higher than that, because when you add more parts, every part makes it more fragile. House of cards are not scalable. However, with Duplo, people have built real houses, like actual physical buildings that people can go inside with Lego, because Lego is scalable. So we want to have our applications scalable, and scalable not just in the sense of like scaled out. but also there's this other buzzword you may have been hearing, app scale. I'm using that term non-ironically. Okay, so if order doesn't matter, we can do crazy things. Like, we can just be like, oh, I have this, have this, have this, and what have you got? Oh, I've got this, and send this, which is like a gossip protocol. This is going to be really interesting stuff, but we need more commutative Duplo blocks that we can plug together with streams. So, in summary, Duplo is, for distributed systems, we need commutativity and streams. Streams are the connectors, and commutativity is the solidness that makes the combinations of blocks predictable. So I've got a couple of these so far that I've written and will be incorporating with like the Vine and stuff like this. This is mostly focused on building simple like data models for real-time applications. But there's quite a few things on the to-do list, like file replication. Like, what if we go back to the real-time cats example, you just upload one photo to one server, and then it takes care of sending it to all the other servers. And that would be really easy, with a few more blocks in place. Replicating Git repos, so you push to one Git repo, and it copies it across your entire cloud, and there's a few, there's still more exploration to do. But the important thing is that there's no silver bullet. There is, we need a whole set of tools. We need a utility belt of all the things we might want to do. So we can use each thing for something. We can solve each problem. We can hit the right sort of nail with the right sort of hammer. Notice people talk about hammers and nails, but there's actually a huge diversity of hammers. And they're all good for hitting different things. So just because you've got a hammer doesn't mean, it doesn't solve all the problems that are solved by hammers. There's like tiny little hammers, and there's rubber hammers, and there's like massive hammers. There's hammers that are like, you have to swing from a crane is basically a hammer. So, and then there's, other sorts of tools as well. But we need a whole set. So this is also important. There are some people who haven't got into the duplex pattern yet, and I want you all to give them a few nudges and influence them if you can. So Socket.io, Socket.io is great, and it's gotten us here, but I'll come back to Socket.io in a second. So this other thing, Share.js, this is really cool. This is for real-time collaborative editing of text. So you can hook it up to a text field, and then multiple users can edit it at the same time. And it just like does the magic to handle that. But the problem is that it has a similar problem to Socket.io, which is like this. So you connect, this is the client side, so you connect to Socket.io, you create a Socket.io object. Now, what sort of object is that? It's some kind of funny event emitter. It's sort of event emittery, but it has a few other weird things, like you can have a callback on emit, and it has other things, like it has rooms and these other things, and that's not a standard event emitter. Like, what really is Socket.io? Like, I think the thing is, this is actually two modules. It wants to be two modules. There should be a thing that does the I/O with the fallbacks and gives you a nice interface, and that should be a stream. And then you should make this thing that's something like a kind of event emitter that you then connect through the socket with the duplex pattern. This would be much, much better because on the one hand, this is a problem that nearly everybody doing a real-time app has. And this is only a solution to some problems. So this is kind of like, it's kind of like a hammer with a bottle opener on it. It's cool, but it's not as useful as those two tools being separate. I propose, this is the important thing. So we agree on the duplex pattern for plugging programs together. We have abstractions that don't do I/O, but directly, but they can be attached to I/O streams, and commutativity, which will make the other things work. So this is you're now all at the fringes of Node.js mad science. So we we don't know what will happen next. We're kind of guessing, and we've got a few crazy ideas and building them and see what we can do, but we need people to push this and see what sort of crazy things we can make. And it recently, it occurred to me just before this my talk that we need a sort of a public, sort of a communal group to discuss this sort of stuff. A lot has been happening in StackVM on IRC, but we need something a bit broader with it's more inclusive of more people who want to, who are interested in this sort of stuff. And Max suggested that he's like, mailing lists are passe, we should just have a Git repo and everyone can just post issues, and that's how we're going to do a discussion. I was like, that sounds like a crazy idea, so sure. So everyone who's interested in writing streams and using crazy streams and doing distributed data and stuff, I just saw this module called Streampunks. Watch it, and then post issues about questions you have or ideas you have, and it will be like a mailing list, but cool. So there's no questions, but they can't ban hecklers. So you've got a few seconds to heckle. Okay, cool. Real-time Cats is looking for. Okay. So there's a new investment opportunity for Real-time Cats. They're gonna be worth millions in about 15 minutes. Thanks very much.